Hi everyone, good morning. Thanks for coming and joining us today. Today, Madhu, myself, Prabhu will be presenting a use case on Databricks we use in First American. We have a number of use cases. We use Databricks for data engineering, AI, and a number of other ways, and Lakehouse and Unity Catalog. Today we are going to present one use case, and we trying to go over, we will have a high-level overview of our company, what group we are coming from, and go over the problem, and then go over what our ML design and process looks like. We go over the matrix, and then finish with the lessons learned and questions. So about First American, how many of you have a experience of buying a home? Or that's good, thank you. And how many of you actually know First American as a name, First American Financial Corporation? Thank you. If whoever hasn't gone through this process, probably title insurance may not know, but we'll go over the process. First American main business is title insurance, but we actually support a lot more than title insurance. You can see we deliver the certainty and trust with the power of the real estate transactions. That's our kind of a purpose of our company. So our major business is title insurance. We also have a settlement services. We provide lender and servicing solutions, which also part of that comes from where me and Madhu comes from. Another one is real estate data solutions. That's basically if you're applying for a loan, or lender wants to check there's any problems with applying your loan or property itself, they come to us for checking for the fraud or the valuations and some other things to us. Another group, we have a home warranty, and we also have a trust. And not to mention, we are 130 plus years old company. We've been there for a long time. We started small, we keep growing. We do more than 1 million plus title insurance every year. We are number one, number two, depending on sometimes we go to number two, we are number one. So, but we also have 16,000 employees across the world. So we support in Australia, Canada, and US is our major business. So about data and analytics group, where we both of us come from, kind of I said in the previous slide, we have the solutions provide for mortgage companies and lenders and some other things. So I'm going to go over that a little bit more. So we provide our solutions to, again, the other insurance companies, title companies, not only First American, but other companies too. We provide to the PropTech, FinTech, oil and gas, lawyers, realtors. I think a lot of different industries users, even including Zillow and some other folks buy information from us. So we basically help them in a number of ways, either making the decisions for their customers or helping them in data analytics, some other aspects of it. So I want to spend a little more time on this slide. So we are a data company within the First American. So think about it as we collect information from 3,000 plus counties and number of courthouses. We buy information from tens of different data vendors. We collect all that information, and if you think about the complexity of our information we collect, each county has its own history, and they are differ from time to time, and they have 1,000 types of events happen every county recording. So you can think of the complexity of this problem. And so we actually take all that information, make it easy for our customers, just enhance and enrich information and provide them easy for consumption. So we are number one in number of data sets, property information. We call it assessor. When you go, if you own a home, you have a tax assessment that happens. Basically that happens from there. We have another big one in ours is the document images. It is basically image when you do a transaction in the county. When a deed, if one of you probably bought a home, you saw the deed, that becomes a signed document, that becomes image, goes into county, and comes as image to us. We have images all the way going back to late 1800s. So some of these documents, we have it, but even counties does not have it. So we actually have much deeper than them and across the different counties. And we have 140 plus 550 million residential properties and all the stats and all the properties over the properties too. So how do we use this information to provide services to our customers? So we have way of giving them through websites and web portals. We have very rich map-based portals that actually customer can come and look for either analytical insights or single property or transaction reports or looking at the market view. There are a number of ways that customer come into web portals and come get their information. We have our own valuation models like Zillow. We provide to lenders. We have APIs where loan origination system or some other customer messaging queue can actually integrate into our API and get the information from those APIs. We do the millions of transactions every day. So we also have used the little modern techniques where customer can come and subscribe to S3 buckets or some data share concept. We can push to them. That's another way we actually share the information to the customers. The other one is called bulk data licensing, where the company can subscribe to entire nation or subscribe to state or a county, and we actually update them on a regular basis. And the last one is in here, advanced data solutions, where customer has a particular need where they have, let's say, 30,000 loans, and they want to get a 20 pieces of information for those 30,000 loans. We take those loans, understand their data set, and basically give them the information need back. So before we go into like an actual problem for today, I'm going to touch on two terms here. Title insurance is a kind of, as I said, is a major business for like our First American. It protects the owner as well as the lender. It's basically, you can read through that, but if there is a problems with the deed itself, ownership, liens, or anything that happens on the transaction, and the customer as an owner is protected as well as the lender is protected. And the two types of policies, one is the owner policy, another one is the lender policy. Owner policy protects the owner, lender policy protects the lender. So the important concept for today is a starter. It's also called a prior or a back. It's called the prior policy or a back title policy. It's a think about this. If the transaction that happened years ago, there is a title insurance policy generated. We call the policy when you get a home and title insurance that becomes a policy. So that previous policy is called a prior or a starter. So we're going to get to that, why that's important. And we are going to dig much deeper into what we did with that particular use case. So I'm just going to touch on the little deeper into the complexity of this title insurance. The reason it's a title insurance itself is a complex. It used to take, I think, few weeks to months. I think in some cases it might still take that. We are much faster. We are trying to get a living title insurance, some kind of a concept where you can actually get insurance much faster. Legal description is one of the complex ones in those documents. It basically states what's the property, defining a property. It could be as simple as your address, when you have address. Or some cases you have something called assessor parcel number, simple number. It can define your property. In some cases, very complex, where they could basically say, okay, this is 3 miles from this cross section. Then you found a Smith's house with this tree, and after that go 10 steps, and then you get a river. You get a 5 steps from this, and so they define that entire thing in a legal description, right? So the challenge with that is basically that how do you make sure that passed on correctly, whether that things changed. I think someone said Smith's house, the Smith's house may not be there anymore. Right, so those are the things, complications come in the legal description wise. Another one we are going to touch on more on is any title insurance we provide, we have to go back all the way to like a parent. So we call the patent. When in the early days of US formation, when government sold the property to private owner, it's called patent. So if you're buying a home today, that might have part of different things. You have to go all the way back to that patent to make sure there are no litigations, easements, or encroachments, or anything that happened over the time to make sure you issue title insurance. That's the reason it takes a long time. Just a couple of them on the personal side. You have situations like people bought it as a married couple, and then one of them got divorced, and one of them is not mentioned in the document. That could get into complications. Sorry, I went the other way around. Okay, this is just an example where I was explaining before. Let's say there was a 1950s, US government sold this ranch to a organization or corporation, and that company divided that into 3 different ranches, sold one of them into 1975, and that to a builder or a developer and that guy basically developed the properties and sold in 2002 and 2015. That person who bought actually sold it. So if you're doing a transaction in 2015, you have to go back all the way to 1950 to find out there were no issues in this particular piece. So the starter concept is basically is that, okay, in 2002, we have done this transaction. We have done all the research that required for that particular property. I can depend on the 2002 the title policy and start from 2002 to 2015 instead of going back all the way to 1950. So that's the concept. Basically, it's easy to say than done because this concept been there for a long time. A lot of them were images at the end of the time, and capturing information from these document images could be somewhere from 10 pages to hundreds of pages sometime, and there are all combined information from 20, 30 documents, sometimes different things. There is no separation, they're not consistent, there is no uniformity. That was a challenge, so if you had to send them to operations keying, I think Madhu is going to go more into this, but if you have to send them to operations for keying, we have to key, two people has to key it. If the two persons doesn't match, the third person has to key it. And there's a QC process. It's a pretty expensive process that used to happen. So take over, Madhu.
Yeah, hope you guys can hear me. Well, first of all, thank you for coming. I know there are a lot of choices out there, but thank you for coming. I sound like an airplane employee, but anyways. So the majority of from here, what we're going to focus on is the problem statement itself and how we formulated the actual business problem into a machine learning problem and how we went about designing the actual solution itself, right? And how we utilized a combination of a good engineering platform like Databricks to solve the problem, right? So we touched upon a little bit about what a title policy is, right? And at a very high level, what I'll tell you is it essentially ensures you're the owner or the lender, right? And when we went through this journey, right? So imagine an internal customer or an external customer coming and giving you 400 million pages or just document images, right? And you have no clue what is in these images. How do you go about understanding what kind of data is in it? Are these pages in scope or out of scope? What are the critical elements I need to extract from this? Do I need to protect my customer information? Those are some of the key critical requirements that we had to deal with, right, when we went into this project. So I listed a few here, and I'll just go into the problem statement in part 2, right? So here's an example of a 1955 title insurance document, right? And you'll get all the way from 1955 to 1900s to 2000s. It's all kinds of varied documents. It is a real unstructured image document. And once you get this image document, you actually want to extract, first of all, you want to find out if the page is in scope or not. What is the in scope page? It means that is it relevant for a title policy or not? The second thing is you want to understand what are the critical elements within this, right? For example, you have who's the title insurance, who's the owner, who's the lender, what's the property address, what's the policy amount, and when was it effective, and what's the legal description of the property here, right? And I touched upon this a little bit. Not all pages are in scope. You do need to split the title policy because imagine if you have a 1,000-page document, not all pages are actually in scope, and I'll show that in a bit. So you want to kind of separate out what I call like weed out the junk pages out, right? You want to identify the individual document types within the policy. And finally, you want to extract the critical fields and redact the important customer information, both for internal as well as external use, and then integrate it into title policy systems for downstream use. Okay, so here's an example of an out-of-scope page, right? I don't know if it's really clear, but this customer gave us close to about 2,200 pages in one single GIF file, right? So,
sorry.
So you can kind of imagine, right, like a lot of these pages are out of scope. Like the next page, this is one of they would embed this page right in the middle of the document, right? So you want to weed this out. So that is the problem that we had to face with. So let's just move on. So then the way we laid out the problem is we first understood the business need behind this, right? So we understand that there's a title policy. It could be lender policy or it could be an owner policy. And then we also understood what are the sub-documents within each of this policy, right? And it's important to understand why these are important, because Schedule A, Schedule B, and endorsements, all it means is Schedule A says that here's the property, here are the different elements, and here's what I'm going to insure. Schedule B, if you have insurance, you know always there's going to be exceptions and exclusions. That's what Schedule B is for, right? Endorsements is something that changes the original policy, either the amount or the dates or something towards that effect, right? So you notice the document title, there are 3 different. I just put a sample of them. There could be 10 different variations of the document title. Similarly, then you have owner's policy.
I think you could click down.
Okay, got it.
Down, put it there.
I don't know. So maybe I should do it here. I can do it here.
This one.
Yeah, let me do it here. Yeah, so sorry about that. So you have owner's policy, and it has the same subcomponents, and like a commitment. Commitment is essentially just a title insurance company saying that I'm committing to give you a title provided you meet certain conditions, right? That's all it is. I'm not going to go too much into this detail. You can quickly read it. Owner's policy just insures the owner. Lender's policy insures the lender. And a loan policy is essentially for the lender. Right? Commitment is just ensuring the commitment itself. I briefly touched upon Schedule A, Schedule B, and endorsements. Right? Schedule A is for the property itself, all the pointers. Schedule B is exclusions, and endorsements is for amendments to the policy itself. Okay, now we frame the functional objectives for the machine learning use case, right? So the first objective is you're going to get a page which is a document unstructured image. Next, you want to determine if the page is in scope or not. The third thing, if it's in scope, then you want to extract the critical elements from the page. Then the fourth thing is, once you extract it, you want to redact certain important customer information as prescribed by legal. And then you want to integrate it into downstream. So you kind of have multiple objectives as part of your problem statement here. Now, traditionally, if you come from a machine learning background, the way you'll formulate this is, let's just say you have a document is in scope or not. You'll find, OK, let me frame it as a binary document classification task. Let me just tell you if it's in scope or not, right? Then the second objective is, what kind of document is this? Is it a Schedule A? Is it a Schedule B? Is it an owner's policy, a lender's policy, right? So that was our second important challenge. Then once we determine it's in scope, then we have to get the entities out of this. This could be owner names, addresses, amounts, dates, policy numbers, right? So we had close to about 150 different fields that would pin the policy to be a very good starter, right? And then I talked about, like, we have to split the starter itself, right? So this is like a start page classification task where you have, let's say, 10 pages, but not all 10 pages are good, right? So you want to form the starter exactly where it belongs, right? And then you want to redact the customer information. It's almost like an object detection task where you want to redact the customer information from the pipeline. So how do we go about deciding how do we address this problem, right? So we talk about a little bit about the trade-offs here. So traditionally, we had machine learning pipelines for document classification. We had pipelines for document entity extraction. We had pipelines for document splitting as well, and redaction too, right? But when you have this kind of pipeline, are we going to orchestrate this one single model after the other, or are we going to orchestrate in a batch, right? That was the important decision for us. So we had some trade-offs, and the second thing is we obviously had to retrain all these pipelines to fit into the title policy data, right? So these were all obviously trained on some other data sets. The second thing is one of the key advantages we had is all the data standardization, like address, amounts, and dates are all standardized, right, so that it fits well into a database. But when it's on a document, sometimes they'll say Jan 1st, 2021 or something. So we kind of say 1/1/2025 doing all of that was built for us, right? So, so that was what we had, but we didn't go with this approach. So we actually went ahead and wanted to orchestrate this as a batch pipeline. And the second thing, we wanted to orchestrate this as a one-step inference pipeline so that we could accomplish all the tasks at once, right? So, and one of the things that the biggest con of this is obviously we didn't have any development effort for this. And the only thing we knew that we had was we had some batch inference that we were really successful, so we were kind of hinging on that prior wins. And accuracy cost was very important, primarily because we were doing a large-scale batch inference. So imagine if you're giving 400 million pages. So when you run such a large inference, cost becomes really important, and accuracy becomes a factor as well, because you have to constantly keep checking the performance metrics at every gate, right? So, and we'll talk through those a little bit more, right? So these are the kind of trade-offs that we went through when we kind of went through which approach should we take, right? Should we use our existing pipeline that we already had and kind of chain them, or should we build something brand new, right? Those were kind of trade-offs that we looked at. Okay, I'll say it's all about the training data, and the reason I'll say that is because the way you formulate the training data will actually mean how you're actually going to infer also, right? So if you have been in the machine learning world, so the way we formulated the training data is pretty simple actually once we understood the problem statement. So we kind of broke the tasks into 3 main tasks, right? Let's determine if a page is in scope. Let's then determine what kind of page it is, and let's then extract the elements out of this, right? Once we did this, then let's just say we had a policy document come here, right? Let's just, in this case, you have an 8-page document. Our first step was to label the document as scope and say if it's in or out, right? So that's our first label, and that would be our first prediction, right? Then a second prediction is, let's figure out what kind of title it is, right? Is it a lender policy or no policy? And then let's just further break it down into a Schedule A, Schedule B, an endorsement, or a commitment. At this point, right, you kind of know that in this particular case, 235 is a good title policy, and page 78 is a good policy as well. So we kind of throw out page 4 and page 6 because they're out-of-scope documents here. So that's how we form the training data itself, right? Let's just see. Okay. And you kind of notice here, I think it's hidden down below, but the policy in this case is 1, 2, 3, and the pages are 2, 3, 5, right? And the policy is at the end is 7 and 8. So that's very important, like how you formulate the training data, because that's essentially how you're going to train the machine learning model so that you have good inference, right? So we kind of went from a multi-objective ML system to one single stage large-scale ML inference by framing all the subsequent tasks as an extraction task, but not as individual ML tasks, right? So let's just walk through what are our different items that we picked as part of this pipeline, right? So the first pipeline is pretty simple once you understand the business problem, once you formulate the training data. So you have an image, you kind of have an OCR, you kind of OCR it. Then you have a unified training data that is available to you. You train a large language model, right? I won't give you any hints what that language model is, and then you have some inference coming out of that, right? And then you kind of post-process the results, right? That's the simple pathway that we chose, right? And this was our first iteration that we did. Why is this important? It's because it's important to kind of set up a very basic vanilla pipeline just to make sure that the batch inference itself is actually going to work, right? So once we had this, but then we started to figure out how much is it going to cost me to run 400 million pages and continuously keep adding millions of pages, right? So this is broken down. This is how we did the cost calculation, right? And we felt that this is very effective because primarily you have 2 parts to it. One is the OCR cost itself, right? And these are just sample costs, just to give you an idea, but it gets you pretty close. So that's the first part, right? Oh, I'm going to OCR it, 1,000 pages cost me so much, right? And then the actual cost comes in when you're actually doing the inference on the inference, right? So here's how much a DBU costs for 10 pages, right? So you kind of have to work through several layers. And our journey on this particular, it took us about a week to come up with this estimate, but once we did this, our estimates for 400 million pages were pretty good, right? So we were very comfortable that we were around the ballpark of whatever amount that we were going to spend on the engineering platform. It would be a good investment for us, right? So that's the cost estimate. Now, so we had the training data, we had the cost estimate, right? So we kind of then figured out what platform to choose, right? And the primary reason when we went down this path, Databricks was an obvious choice for us, primarily because when you run large-scale inference, the GPU availability for running large language models is primal, right? And Databricks was the only cloud provider at that point who was giving us this availability, right? And also, the engineering of the Databricks inference is very, I would say, structured for both for development and for engineering as well. We also had done a large-scale inference jobs with other image processing pipelines, right? So we were very successful with Databricks, right? So that's why we chose Databricks. And the other key features that we actually included, one is obviously observability, right? So you kind of know how much GPU utilization is happening. Scalability is very important for us, primarily when we deploy the inference model. For us to scale from one GPU to 4 GPUs, it takes us less than 30 seconds, right? So that is very important for us. And Databricks was the only engineering platform that would help us scale that quickly in that short time, right? I do want to call out both Joe and Feva. They've been amazing customer support and partners during the entire process. So we had great support from a lot of the engineering leaders within Databricks, as well as their customer and partner teams here. Okay, so we actually, in terms of the language models, we actually played around with quite a few. We played with, I won't name every language model, but we ended up with Llama primarily because we were able to, it was tightly integrated into Databricks, right? That's the first and foremost. And then the second thing is we could fine tune it. We did several iterations of both full weight fine tuning and then parameter efficient fine tuning as well. And then once we fine-tuned, we noticed that the results are more consistent, and the number of hallucinations and the accuracy kept getting better through iterations, right? And we were also able to actually scale deploy it on an A100 or an H100, right? So it was pretty easy for us once we deployed those. So those are our design choices. So in terms of our training pipeline, right, it's actually pretty simple, I would say, once we knew the entire landscape. You have a blob storage. You had broken out our 400 million pages into several different containers, right, very divided, very well organized. That's the first step, right? Then we had an OCR job that would continuously look at these blob containers and run the OCR. Our choice for OCR was Google Doc AI, primarily because we felt that it maintained the read order and also had good quality on the image itself, right? Then we fine-tuned the large language model, Llama, in this, and then basically stored our predictions in a Delta table. Training input for the large language model was primarily two things. It's pretty self-evident. One is the OCR, the prompt input with the field value for the ground truth. Our parameters were, obviously, it has good context length, so we're not worried about that. But the learning rate is where I felt Databricks really helped us to pin exactly which learning rate. And this is pretty important, primarily because it tells you it's linear to both the GPU compute time and your inference cost, right? So that's why it's very important to pin the learning rate here. We ran it for 5 epochs, right? So that's essentially where. This is our training pipeline. So it was pretty easy to train. But then when we started doing the inference, here you'll notice we actually don't stop at the ML predictions. So there's some post-processing happen. And what the post-processing itself is dates, addresses, title company names, all of those address standardization, all that would happen in post-process predictions, right? And then that would be sent down to the downstream applications for title exchange. Okay, so in terms of the streaming batch inference, I think, so the way I kind of explained this a little bit, right? You have a big blob storage container, very well divided. Then you stream the OCR text, and then you kind of run the AI query, which is kind of your inference point, and then you store the results in a Delta table. So the left side is a latency graph directly from Databricks. And what you'll notice here is 50% of our results pretty much finished within 5 seconds. And 90% of our results finished around, I think it's about 10 to 15 seconds. Sorry, it's about 30 seconds, right? So that was our latency, right? But apart from latency, what you notice on the right side is the throughput graph. So the throughput graph is very important, primarily because the way we measure throughput is per second, right? And that matters quite a bit. So if you notice, all the responses are kind of around the 13-second mark, right? So what that means for us is in 13 pages in 1 second. That's what it translates to us. So I'm able to process 13 pages in 1 second, which kind of roughly translates to about 47,000 pages in 1 hour. In 24 hours, that means about slightly over 1 million documents, right, on one GPU, right? And then you kind of scale up the number of GPUs, and you're able to process that many pages in batch inference mode, right? So that is our story, right from problem statement to framing the training problem, and then setting up the batch inference, and kind of scaling it so that we could run this at large scale. And you kind of, once you set this up, you have a pipeline where you can kind of run this in batch mode continuously. Okay, I'm going to hand it off to Prabhu, who will talk about more of the metrics and how we went through the other lessons learned as well.
Thank you, Madhu. So I just want to touch again, I think when we started with the Databricks early last year, there was only a kind of using API. You can fine-tune only using APIs, and you can inference only using endpoint. I think it was very early stages, collaborated closely with the product engineering team, able to do it pretty quickly. And actually, eventually, AI query came in that simplified quite a lot of processing. You don't need to do all that stuff yourself. And that was really, really important for us to make it success. So like Madhu was explaining, our training data set needed a quite lot of thinking, how you want to capture this information. We have a set of experts in offshore. We would basically, who knows these documents, would provide in a files for us to kind of use that for evaluation and training. And we had to, like he was talking about in scope, out scope, what the document type and the subtype, and also the fields and everything. As you can see here, we went through the multiple iterations, right? Basically, we do this in all the projects too. You start from somewhere, number of documents, we give that, we do the evaluation. Because it's mostly classification problem, whoever worked on AI, ML, classification problem, best metric to use is F1 scores, right? I can basically balance between precision, recall. And so there are different categories of information that we had to capture. I think like we call header information, like a policy number and some other things. Then you have a land information or the property information. You have address, city, and APN and some other things that comes up. And one important part of the thing is, I think once we do the first iteration, we would get a feedback and say, okay, this is not working well. Then we pick and choose, okay, we need to label another set of documents for this set of documents, a set of fields, and also the set of features in a way. So we give that back, and we get the back and do the iteration. We did like 3 times. At the end, I think we did around 40K plus pages to get to this accuracy. So it's the another thing is that I think human does some mistakes too. You're not going to get 100%. So we do have some cases where it's only like 80s or 90s. Most of them are above 95. And one of the things we kind of Madhu touched on, this is the second set of fields, which is kind of basically on the person name, but this similar concept. So we also have a lot of this information. We use our existing data sources for validation. You can think of LLMs always kind of talk about hallucination. How do you make sure we don't have hallucination problem with these extractions, right? So one of the things we do is address, right? If that address was existing before, I extract this address information, why don't I validate with my existing data sources? If it's there, I'm confident this is a valid address. Same thing with the date, same thing with the name. Sometimes there are a number of things we validate with it. So that's how we get a confidence, and the post-processing that actually helped us quite a bit on standardizing and validating to make sure we are confident. And at the end of it, I think Madhu touched on a little bit there too, is there are fields that we are not confident, they're really critical, need to go to human review. So that we basically send, I think, less than 10% of them actually goes to human review. They actually correct it and give it back. So this is another set of fields. We have APNs. I kind of talked about a parcel number, address. I talked about legal description blob. So lessons learned. I think Madhu touched on this also some of these concepts before. Defining the problem itself clearly, right? I think one of the challenge I think probably most of the folks have is when we talk to product folks, they want everything, right? That's the challenge, right? So basically, the challenge is that they wanted 175, 180 fields. So we had to kind of work with them in multiple iterations, say, what do you need? What do you need exactly, right? Don't ask for everything. So we got to start somewhere and basically iterated on them. We are actually started probably 75 plus fields. Here today, 175 plus fields. We enhanced quite a bit. And every time they add a field, now I have to go for a labeling. I think they have to understand the cost too, right? So that's another part of it. Madhu touched on design choices up to some extent. So ML objectives, he touched on a slide, right? So for us, cost was really important. I think we have an existing platform that does the real-time inference. I think what Madhu was touching on, you have a document classification, the splitting, and also the extraction. So if you had to go to real-time extraction, the cost would have been 10, 15 times of the cost we did with the LLM approach. So that's definitely important. And when we looked at the LLM itself, there was option of using prompt engineering with the closed models versus using the smaller LLMs with the fine-tuning, and then using the PEFT and quantization to make them smaller to get the cost reduced. So those are also considerations we have to part of the design. So another important aspect for us actually is we are kind of data manufacturing company. We always say create, maintain, deliver. This is kind of our mantra for our business, right? So one of the things for all of our pipelines is we want to capture information as it exists on the document. So I think when I train that model, you can expect there is less hallucination, as well as you can expect that to be in the document. So when we give it to operators, human operators too, we don't want them to change anything from the document. They want them to be king as is on the document. So it can be used for our training too. We talked about storing all the predictions. So we talked highly about the integration. I think our pipelines, even though we're talking ML, we have a quite bit robust pipelines that goes with the integration platforms all the way from data acquisition to ML process to post-processing to going to product and customer. We have to integrate all this process with everyone. Right, so I think some of the things we learned, definitely part of this is, I think, as we transition from real-time to this batch, there are set of steps involved in real-time. We missed when we start implementing the batch. We have to make sure this address foundation happens. There is a validation happens for the names, and there is a validation happens for the dates, normal age. So we had to put all those things part of this lessons learned. Finally, at the end, it kind of hits the customer, right? So basically, what happens is we extract all that information, we load into kind of a delivery, like a databases, and then we have a platforms that actually can query and search and return back to the customers. You can see here, basically, we have search fields. Either I cannot read well myself here, but I think address, APN, or sometimes they have a legal description, lot, block, and some other things. And as we're going over the first few, an example where you're trying to buy a home or something, that particular home, we identify that home, one of those rectangles is one of those homes, and we try to pull the policy from the history. And so, okay, this is the policy I found. And if you don't find a policy for the particular home, now actually can I find a policy for my neighbor? Because if you think about these two properties where a parent has the same parent. So if I cannot find a policy for myself, can I find my neighbor? And that can help me to reduce research. So we kind of use all that the kind of technique to reduce our cost of title insurance. So this is how the policy document image looks like on the right-hand side, which is actually pretty big sometimes. I think that's all for today.